Good morning, good afternoon, good evening, wherever you're watching me from. This is Osman Tutor, where chemistry is made easy for every student to learn. Today we are looking at a special topic. I'll take it simple and very short. That's the periodic table. And why I'm taking this topic at this period is because many students they find it difficult to understand the simple concept behind the periodic table. The periodic table of elements shows the arrangement of elements in order of increasing atomic number. And you see, you need to know all these things step by step so that you will know the properties of elements as it applies in all other reactions. Now, I said the periodic table shows the arrangement of elements in order of their increasing atomic numbers, not according to their increasing mass number, but the atomic number. Now, this have been, predicted so long ago by so many chemists, by Mendeleev, Newland, and Lothar Meyer, and so on and so forth like that. So now, let me just break it down. The atomic number, like I said, it is the number of protons in the nucleus of an atom. So if an element is having a proton, just one proton, that simply means that it's going to have the atomic number of 1. If an element having two protons, it's going to have atomic number 2. So when you look at the periodic table, do not it's not ambiguous, and don't be confused. Don't be disturbed. Oh, why are they arranged this way? Why is hydrogen number 1? Why is this so and so element so and so in this place? Now, so hydrogen has just one proton, and so it is the first element in the periodic table. That does not mean that hydrogen is the first element to be discovered. All right, that's by the way. So the periodic table, like I said, shows the arrangement of elements according to their increasing atomic number. Now, in the periodic table, we have a breakdown of the element into groups and periods. Now, when you hear the word groups and period, what does it mean to you? Now, it's also break down further into blocks of element or families of element. Let me take it one after the other. When we say group of element in the periodic table, group, what does it mean? The group arrangement simply means the arrangement of element vertically. The vertical, arrangement of what element in accordance to their what to their family. When I say family, when you look at the first group of the periodic table, group 1 element, you look at it from top to bottom, and all those elements they have something in common. What is common to them? If you write their electronic configuration, you are going to notice that they all end with 1. Now, that simply tells you that all the elements that have their electronic configuration end with 1, they have, they belong to group 1, in the periodic table. So no matter how, all these elements, they have similar chemical properties. Now, one good thing and one beautiful thing about this arrangement is that it also shows the reactivities of those elements in those groups. If you look at group 1, for instance, like I said, the group 1, they are called, the family name is alkali metals. I will talk about the meaning of alkali metals, shortly now. Now, they are called alkali metals. And why? Because whenever they react with water, they simply produce an alkali solution. That is why they are called alkali metal. Alkali metal. So now the group 1, as I was talking about it, as I was still, I'm still on the group 1. The group 1 element, they show their activities as you are going down the group. So the activity of group 1 element increases down the group. What I mean by down the group? When you look at lithium, lithium is the first in the group. Please, when you see some periodic table where they place hydrogen in group 1, please don't be misled. Hydrogen does not belong to group 1. Group 1 element actually begins with lithium. Lithium is the first member of group 1 element. That's the alkali metals. So we have the lithium, we have sodium, we have potassium, we have rubidium, we have cesium, and we have francium. So meaning that lithium is the least reactive element in group 1. Now, that tells you that if lithium is the least reactive, that means francium is the most reactive. That's what I mean by reactivities increases down the group. As you are moving down the group, as their atomic number increases, their reactivity also what increases. Then something also tells very very important about this. These arrangements also tell us the properties of those elements, their melting points, and so on and so forth. So when you look at those group 1 elements, their melting point decreases as you go down the group. No wonder the reactivity increases. Why? That means francium is a very very soft metal, very very soft metal compared to sodium, potassium, and above. So francium is very very soft, and that is why the reaction of francium is very very violent. In fact, if there's another word more than violent, I will use it. So it shouldn't come near water at all. If not, if you come in contact with water, the result will be devastating. So that is just about group 1 element. The next group in the periodic table, we have the group 2 element. They are called alkali earth metals. Alkali earth metals. These alkali earth metals, they are the group 2 element. And in this group, group of elements, they also react with water, but their reactivity also increases as you move down the group. The first member in the group 2 element is the beryllium. Go, moving down like that. Now, beryllium is not as reactive as magnesium, calcium. So the reactivities in those groups increases down the group. Now, like I said, we have altogether we have 8 groups of elements. So today I would just talk about the breakdown of the periodic table. I will take time to deal with the properties of each of the group members one after the other in the next subsequent videos. Now we have the group 1, the group 2, the group 3, 4, 5, 6, 7, and 8. So now all these groups, they have their specific or scientific names given to them, but not all of them will mention in this video. But I want you to understand one fact, that some of these names that are mentioned, it is in line with their nature of reactivities, with the way they react. That is why they give them those names. So, like for instance, you have the halogen in group 7. They are very very reactive non-metals. You have the group 8, which are called noble gases. They are not reactive at all. Why are they not reactive? Simply because these are the elements with complete, electron shells. The outer shell is completely filled up with electron, and so there is no way they can give out electron. There is no way they can take in electron. So they are we call them fully filled shell. They are fully filled shell. So they are not reactive at all at this level. So they are called group 8 element or group O element, or the noble gases. So these are the basic 8 group of element in the periodic table. Now the next classification is the period. Now before I move to the period, something just struck my mind now. I need to let you know that how do you apply this group of element in the periodic table and identify element? If you come across them and they ask you question, which group does so element belong? What will be your answer? Now, the group that element belongs to is characterized by the number of valence electrons they are having. So, if an element has valency of 1, that means it belongs to group 1. If it has 2 in the outer shell, that means it belongs to group 2. So, the valence electron of each element tells you the group it belongs to. And also, I will also tell you how you can apply all these valence electrons in the subsequent video. Now, the next one I want to talk about now is the period. What is a period? Now, the word period simply refers to the horizontal arrangement from left to right. From left to right in the periodic table. The horizontal arrangement of elements in the periodic table. That is the period. So altogether in the periodic table, we have a total number of 7 periods. 7 period. Now, where hydrogen and helium makes the group 1, the period 1, then you move to the last block, the lantana and the actinides, you find the last that period 7, you find it there. That's under that francium side. So now these are the basic breakdown of the periodic table. Like I said, it is broken into what? Groups and period. While group is the vertical arrangement, period is the horizontal arrangement. Now, what does a period tells you? What is the importance of period? Now, and how do you know which period does a particular element belong in the periodic table? Now, let's take, for instance, look at hydrogen. When you write the electronic configuration of hydrogen, it has just only one electron shell. And that electron shell is occupied by just one electron. And moving to the right, extreme right, in the periodic table, you find helium. Helium has just one shell, just like hydrogen. However, it's having 2 electrons in its shell. That's a complete shell. I'll talk about that as well. Now, these 2 elements, they form the first period of the periodic table, the first period. While francium is the 7th, and other elements they what form the 7th period at the bottom of the period. So if you count it from the top to bottom, you have a total number of 7 periods from left to right, and you have 8 group, 12 to bottom. That is period. Now, the number of shells that an element has tells you the period it belongs. So, for instance, if an element has just one shell, that means it belongs to period 1. If an element has 2 electron shells, that means it belongs to period 2. If an element like lithium is in period 2. Now, lithium has 2 electron shells. The inner shell is fully filled, that is the K shell, it is fully filled, while the L shell, outer shell, has just only one electron. But what we're talking about is that because lithium is having 2 electron shell, we place lithium in period 2. And all those elements in that period, they belong to what? Period 2. Whether they have 10 electrons, altogether we have 2 electrons in the inner shell and 8 on the outer shell. As we move to neon and lithium, they are in period 2, from left to right. So the period of element is determined by the number of electron shells that the element has. So by this now, I expect you to know the difference between periods and group. If they ask you an element X react with maybe water and produce a solution that is alkaline, and and so on and so forth, and this element has, let's say it has 19 protons, and just like that, and they ask you which period does this element belong. Mind you, look at it, they've given you a clue that this element has 19 protons. 19 protons means that atomic number is number 19. And when you look at it, the element in the periodic table, potassium happens to be number 19 in the periodic table. So how do you now determine which period it belongs? Now, when you now break down the electrons of potassium into the electron shell, you find out that potassium is having 4 electron shells. The first shell being occupied with 2 electrons, the second 8, and the third 8, and the fourth one 1. Now, that tells you that potassium is having 4 electron shells. That means potassium belongs to period 4 in the periodic table. Now, if you look at potassium, like I said earlier on, the number in the valence shell, which is 1, brings potassium back to group 1, period 4. Group 1 because it has one valence electron, and period 4 because it has 4 electron shell. By this, I expect you to have been able to understand the basic interpretation of the word groups and period in the periodic table. Now, quickly, let me talk about the importance of this classification. Now, like I said, the classification of elements helps you to understand the key properties of all these elements in the periodic table. Their chemical properties, their physical properties. This arrangement will help you to identify, because all the elements in the same group, they have similar properties, unlike period. Now, please don't understand this statement that the fact that some elements belong to the same period will have similar properties. No, it doesn't work that way. It's only groups of elements that have similar chemical properties. Now, but if they belong to the same period, they can never have the same properties at all, because they don't have the same number of electrons in the valence shell. Even though they are in the same period, even though they have the same number of electron shell, but not the same number of electrons in those valence shell. For instance, look at chlorine. Chlorine is in period 3 with atomic number 17, and is having 7 electrons in the valence shell. And we look at sodium in group 1, is having 3 electron shell as well, but having 1 electron. While sodium is a metal, and it reacts with water and so many other things, acid and so on and so forth. Chlorine, in the other way around, is a non-metal. Chlorine is a gas, while sodium is a metal. So they don't have the same property at all. They are not similar. So you should be able to, set a clear boundary between element being in the same period and element being in the same group. Now, the next thing I'm going to talk about now is the families of elements in the periodic table. I will call this one the SPDF block. I call it blocks of elements. Just like in every estate, let me use the word estate for instance. You see, they say block of flat, true flat, all those things. Now, in the periodic table as well, we have blocks of elements. Now, these blocks of elements simply tells us the groups of elements that have similar but not the same properties. Similar, something is common to them, but not all the same. Now, there are basically we have the S block element, we have the P block element, we have the D block element, and we have the F block element. Now, the S block element, why are they called S block element? Let me break it down. When we talk about orbitals, we have S orbital, we have P orbitals, we have D orbital, F orbitals. So this name SPDF is derived from that orbital, the orbital system, of studied element. Now, the S block element, they are the group of elements that has their valence electron. Valence electron is the electrons in the outer shell. Now, they have their valence electron in the S orbital. That's why they are called S block element. So element like sodium and calcium, they don't have the same properties. They don't have the same valence electron, but they belong to the same block. Why? Because looking at the arrangement of electrons in the valence shell, their valence electron falls on the S orbital. When you write it using the SPDF notation, we have two ways of writing electronic configuration of element. Either you use the KLMN, that's the energy level, or use the SPDF notation. If you are using the SPDF notation, that will be easier for you to understand this particular topic. So when you look at the SPDF notation, you notice that sodium has its valence electron in the S orbital. Likewise, calcium. Calcium is in group 2, sodium is in group 1, but because their electron is in their valence electron fall on the S orbital, that is why both groups of elements, group 1 and 2, they are called S block element. Likewise, all other elements. Now, the next block is the p block. When you write the electronic configuration of this element, you notice that the valence electron fall on the p orbital. Don't forget the p orbital is subdivided into three: the ps, py, and pz. Whatever the number is, so far it falls on the p orbital, then that element belongs to the p block. So the p block element, they are the element that has their valence electron in the p orbital. However, the next block I will talk about now, the next family, they are a bit different. In fact, completely different from all other elements. This group of elements, they are called the transition element, transition metals. The transition metals, they are so called from the word transition. The word transition simply means changing. So these transition elements, they actually have the capacity to change, based on the configuration. They can change their colors in reaction, and not only that, they have more than one valence electrons, or we call it oxidation state. So because of that, they can form different kind of salt color formations in the solution. They form colored ion and so many things. That is why they are called transition. They have properties differ completely from every other element in the periodic table. So the D block element, they are called transition metals. This transition metal will take us a special class, which I'm going to take it as a topic on its own in the next video. The transition element will be my next topic in the next video. So please, I want you to go and make research on the transition element before then, so that you can ask questions in the comment section, ask question, and send your question, and I will answer your question. Please, at this point, I will move on to the next block, which is called the F block. The F block element, they are divided into two. They are the actinide and the nitinide series. This F block element, they are at the lower part of the periodic table, and most cases they are all radioactive. They are radioactive in nature, so they are heavy metals. Okay, so they are actinide and the lanthionide series. So at this point, let me pause a bit here. So I'm going to talk about each block of element one after the other with their periodicity properties, in the subsequent video that I'll be producing. So please, don't forget to like, share, and subscribe to our channel. Please do ask a question in the comment section. Please, you can post your question there, and I will answer your question, appropriately. Thanks for watching. See you in the next video. Thank you.